All right, hello everyone again. Welcome to the PASS Application Development Data Time Travel with SQL Server Temporal Tables webinar. We're excited that you could join us today for Sam Nasser's presentation on data time travel with SQL Server. This live webinar is delivered by expert speakers from the PASS community or IT community at large. The webinar will be recorded and a link to the content will be posted on the PASS application development website after the event. My name is Carnegie Johnson. I'm a new co-leader for the PASS App Dev virtual group. I'm excited about volunteering in our community. I will do my best to facilitate great content and a fun learning environment for all of us. I look forward to our upcoming events and meeting all of you virtually or in person, hopefully. You may learn more about me and our leadership team by visiting our app dev website, and I'll repeat that URL in a little bit. Before we begin the presentation, I have a few more introductory slides, and then I will hand it over to our presenter. All right, if you require technical assistance, please type your questions into the question pane, and someone will assist you. The question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time. And once we get to the Q&A portion of the session, generally at the end of the presentation, I will aggregate the questions and read your unanswered questions aloud to our presenter. You may be able to zoom in on the presentation content by using the zoom button that's located on the top of the presentation window. Please note that there will be a short evaluation at the end of the webinar, so your feedback is most important to us. Please take a moment to complete the evaluation. The evaluation form will appear in a new web browser window after the webinar ends. Now I'd like to take a moment to thank our virtual group sponsor, Soaring Eagle Database Consulting. This webinar is made possible by Soaring Eagle's generous support. Sponsorships are the reason this event is available free of charge to all of us. If you would like to learn more about our sponsors, or you would like to become a sponsor, please visit our appdev.pass.org virtual group homepage, where sponsors are prominently listed and their respective contact information is available. Now for some fun things. We're going to do a webinar prize giveaway. So during this presentation or after the presentation, we are giving away $150 in US dollars in Amazon gift cards via prize drawing. There will be 3 random winners chosen. The prizes are $75 for the first prize, $50 for the second prize, and $25 gift card for the third prize. To be eligible for the drawing, you simply needed to register for this event and attend this webinar and complete the closing survey. So the closing evaluation is important. So you may also increase your odds of winning and earn bonus entries for the drawing by connecting with us via social media. So if you subscribe to our YouTube channel, which is youtube.com/passappdev, and send a message with the words hash 2018 June or JUN06 and hash pass app dev contest with your registration email. That'll earn you 1 bonus entry. And hint, the message is sent via the YouTube site and not your direct email client. If you already subscribe to our YouTube channel, you may still earn the bonus entry by sending the previously noted message and text. And I will paste these in our chat window as we begin the presentation. Our second bonus entry is to follow us on Twitter at PassAppDev. Send a Twitter direct message with the words hash 2008 JUN06 hash pass app dev contest and your registration email, and you'll earn another bonus entry. So in total, you could have 3 entries, one for simply attending and completing the registration, and 2 additional bonus entries if you are a YouTube channel subscriber and follow us on Twitter. Now, if you already follow us on Twitter, you may still earn the bonus entry by sending the previously noted message in text. All right, so in the example here on the slide, just simply replace where it says reg email with your registration email. Official drawing rules are available upon request. Presenters, sponsors, organizers, moderators, and their respective immediate family are not eligible for the drawing. Okay, Past Summit. Past Summit is our community's flagship event, and it is happening November 6th through 9th in Seattle, Washington. So Past Summit is the largest conference for technical professionals who leverage the Microsoft Data Platform. Attend Past and immerse yourself in deep dive technical sessions, learn best practices, and discover new tips and tricks. For more information and to register, please visit our appdev.past.org virtual group homepage. Use the link on the AppDev Pass homepage during your registration and enter the code VGDISHX2H as you see on the screen. You will receive a $150 discount at the time of registration, and also the virtual group, our app development virtual group, will receive credit so we can offer additional prizes in the future. So please support us, and if you want, you can share that code out with other colleagues. Okay, so this Past Application Development Virtual Group webinar is presented by Sam Nasser. Sam has been a software developer since 1995, focusing mostly on Microsoft technologies. He's a senior software engineer with NIS Technologies, where he consults and teaches clients about the latest .NET technologies, including .NET Framework, SQL Server, and Azure. Sam has achieved multiple certifications from Microsoft, such as MCSA, MCAD, MCTS, MCT, and he is a great leader in our community. He's the leader of Cleveland's C# and VB.NET user group. They're a very, very active user group with great content. He's led that group since 2003. In addition, he's the leader of the .NET study group. He's an author for Visual Studio Magazine and a Microsoft Most Valuable Professional since 2013. So when Sam is not coding, he loves spending time with his family and friends or volunteering at his local church. And he's an all-around great guy. So without further delay, here's Sam Nasser with data time travel with SQL Server temporal tables.
Thank you, Carnegie. Good afternoon, everyone. Glad to be here with you, and I'm looking forward to discussing temporal tables with you. Temporal tables essentially is another name for system version table, and this is based on a ISO ANSI standard that was developed in 2011. It has newly surfaced in SQL Server 2016 and obviously carried over into SQL Server 2017. The whole purpose behind temporal tables is that essentially it maintains the current record as well as any past states of modified rows within that table. So we're maintaining a history as we're going, showing updates, deletes, that sort of thing, and we'll see that in more detail as we step through the demo. Everything that I'll be showing you today is available in all editions of SQL Server 2016 and 2017. And the beautiful part about temporal tables is that it's all implemented via T-SQL. There's no additional configuration needed. You don't need to install any additional components. You can implement everything through SQL Server Management Studio and no additional plugins. Jumping right into it, the requirements for setting up a temporal table are as you see here. First and foremost, we need a primary key on the table. And then second, we need 2 period columns that need to be the date time 2 type. We can give it any name we want, and we must make it non-nullable. This is going to be used for tracking when the record goes into existence, and likewise when it goes out of existence, meaning it is no longer valid or it has been updated. So we set up a start column that must include the clause generated always as row start, and we also must specify an end column that would also include the generated always as row end. And once we declare these two columns, then we're going to specify those two column names in the period for system designation, as you see there in the third bullet point. And then in addition, we need to specify that system versioning will be turned on. And we also need to specify the name of the history table that we're going to be pointing it to. So I know this seems like it's a lot to digest from the get-go, but there's an example of some sample SQL listed down at the bottom that where we're creating a table called department. And there you see all the requirements implemented there. So we have a department ID set up as our primary key. We have our valid from and valid to, which are our date time to fields. And again, we specify the generated always as row start, and we're specifying that to be not null. And the same thing with the valid to field, which is also date time to, and we specify that it's being generated always as row end, and that is also not null. Furthermore, we utilize these two fields in the period for system time clause at the very bottom of that SQL statement there. And so you see the valid from and the valid to specified. And then at the very end, we're specifying that system versioning is going to be turned on, and we're going to specify the name of our history table. So here we just specify the name of the history table, and then by default, what's going to be happening is it will automatically create a table that's identical to the current table, and it will just call it department history. So all this is implemented through one T-SQL statement, as you see here. We're creating a table from scratch. We're not doing anything ahead of time as far as configuration, and it's going to create a historical table for us on the fly. Once we have our table created, querying temporal tables is very simple. Essentially, we utilize the standard select clause, select star from department, and then we specify the for clause where we're going to be mentioning the system time that we want to go back. So essentially, we're doing time travel with the data. We want to say, give us the records that were valid as of a specific point in time in history. And then we can additionally add other clauses on there, such as the order by employee ID. So where is this useful? It allows for querying a table at a specific point in time, like I mentioned. It's great for slowly changing dimensions of a data warehouse. It's perfect for auditing of when the change was made as opposed to who made the change. And it shows when the record was valid and when it expired. It's also great for recovering from accidental data loss. So if you have a developer or a user who deleted a record from the table, we no longer have to rely on going back to a previous backup, doing a restore, copying the data over, and then going back into production mode after that. But rather, everything is available to us. We're maintaining a running history of everything that has happened in that table. It's also great for anomaly detection. And what I mean by that is, take the scenario, for example, where a customer, if their record got hacked and their address has changed more than once, if you just had a conventional table, you would just see that the latest update to that address. But if you have a historical or temporal table, you can see that the address has changed multiple times, which may raise a red flag, or should raise a red flag, I should say. And lastly, it's also good for repairing row-level data corruption. So if we have any data that's corrupted within that record, we can just simply rely on the historical table and then copy the data from there, and then we're off and running once again. For enabling temporal tables, so this can be done for existing tables as well as for new tables. So in a previous slide, we saw that we can specify additional clauses from the get-go as we're creating a new table. But in the case where we're adding temporal tables to an existing data table, basically it must be done in a alter table statement. And what we're going to be doing there is we're going to essentially be adding the two time period columns, the time start and the time end. And so here you see an example down below for altering table employee. We're adding start date column and end date column. And again, you'll notice that the field is a date time to type. we're specifying the clauses generated always as row start and generated always as row end. Both of those fields are not null. And because it's an existing table that we're adding on temporal fields, we obviously need to specify a default. So we're going to give it a default for the start time as of January 1st, 1900. And then the default for the row end is the year 9999, December 31st. I certainly hope to live that long, but highly doubtful. You'll be seeing this date of 9999, and we'll refer to it as infinity, essentially, going forward in the presentation. So whenever we see a record that has a end date of infinity or a row end of infinity, basically that's indicating that the record is still alive, so to speak. It's the most current record that we have in our table. And then after we add in those two fields, you'll notice down on the bottom, we have an additional alter statement. So this is the second alter statement that we need to implement. And what we're doing here is after we added the start date and end date to our existing table, we simply need to specify that system versioning will be turned on. And what this does is it essentially synchronizes it with the historical table. So as we'll see in the demo, any change I make to my current table will immediately be reflected in my historical table. And so what this is doing, it's essentially marrying the two, the current table and the historical. And I'm specifying the name of my historical table here to be employee history. Once I have my table set up, whether I used an existing table and modified it to be temporal or created a temporal table from the get-go, I can query it using these subclauses that are included within T-SQL effective 2016. So I can utilize the as of and then specify a date time field. I can also say, give me the records from the start to an end period or between start and end. And the difference there is that with the from and the between is inclusive of the end date, whereas the from is not. And as you see there highlighted in the chart. So that's the two differences between those two subclauses. One is inclusive and the other is not. Contained in the fourth clause you see there, where we're going to specify a start date and an end date. Essentially, it's saying return the records that have both lived and died, for lack of a better word, within this time frame. All the previous clauses say simply return the records of when the record was current. Here, we're looking to see that a record was current and expired within or contained in within those two time parameters that are specified there. And I'm sure you all have many questions, and they will be answered briefly by this demo. So what I did here is I have a demo script that's created, and let me scroll all the way to the top. And as mentioned, this basically runs in any edition of SQL Server 2016 or 2017. And so let me go to my database. I will delete my Temporal Demo DB2. I'll change to the Temporal Demo DB2. Oh, excuse me. I need to go the other way. I need to go to another database and then delete the Temporal Demo DB2. So now that that's deleted, I'm going to create the same database. So I'm starting from scratch. And the reason I'm doing this, I want to show you basically everything from the get-go. So nothing is taken for granted. And again, everything's implemented via T-SQL. With no additional configuration prior to. And let me go ahead and refresh my databases. And we see that I have a Temporal Demo DB2 available to me. Under tables, it is currently blank. So at this stage, what I'm going to do is create just a standard table called Territory Managers. So this is going to be for a scenario where I have customers, and the customers are tied to territory managers that are managing those customers. So my territory managers table will be just your standard table, nothing fancy about it at all, just the primary key. And I'll go ahead and let me switch to Temporal Demo DB2. And then I will go ahead and create territory managers. That table is now created. Now we get down to the nitty-gritty. Now I'm going to be creating a customers table. The customers table will be a temporal table. And as we discussed with temporal tables, there are several requirements that need to go into place. First and foremost, I need to specify the primary key. So I have that as my identity field. Second, I need to specify sys start time and sys end time. These are going to be date time 2 types. Keep in mind, I can call the names anything I want. I chose sys start time and sys end time, but the requirement is they have to be date time 2, and I need to specify the clause generated always as row start, and of course, it needs to be not nullable. Once I have these 2 fields defined, then I will specify them in the period clause, where I'm specifying period for sys time, and there are my 2 fields that I defined, sys start time and sys end time. Once I'm done defining my columns inside the parentheses here, the next 2 steps are essentially to turn system versioning on and set the name of my historical table. And here I chose DBO customer historical table. So up until this stage, again, keep in mind, I have no tables created in my temporal DB2 other than my customers, territory managers. And there we see territory managers. So now I'm going to create customers. And with this one clause, what it's going to do, it's going to create 2 tables, customers and the historical table for the customers. So I'll go ahead and execute that statement. Now that completed successfully, I'll refresh my database. And under tables, we see the territory managers table that I created. And let me expand my Object Explorer. And then you also see my customers table. Now, for starters, you'll see that the icon listed for territory managers is different than that of the customers table. In addition, because the customers table is a temporal table, you'll see that it has system versions in parentheses next to it. When I expand it, and I'll expand territory managers as well, I see the expected columns, keys, constraints, and all the other folders that are pertaining to that table. When I look at the customers table, I see that I have another table under that customers table, and that table is called customers historical table. When I expand that, I see that that also has its own set of folders for columns, constraints, and indexes and statistics. So just by utilizing the one statement here, I created 2 tables, and basically by me specifying system versioning on and specifying the name of the historical table, the SQL Server database engine simply took this schema that's specified for the customer table and then duplicated it for the customer's historical table and just giving it a different name. And as you see here, the columns are identical for the most part. One of the exceptions is in the customers table, you see that I have ID as a primary key. However, in the customer's historical table, it is not set as a primary key. It's just simply an integer field. And that's because we're going to be maintaining history. The ID field will no longer be a primary key in the historical table. It will just be an integer field for the simple fact that we can modify a specific record multiple times over and over again. So it's going to have the same primary key, and that obviously won't work. So think of it similar to a data warehousing scenario, where essentially you remove the primary keys because you're storing a lot of updates for that current record. Continuing on, what I'm going to be doing with my customers table is I'm going to be creating a foreign key, and what I'm going to be doing is tying it to the territory managers. So I will alter the table customers, and notice the change here will only be implemented on the customers table as opposed to the customers historical table. So I'll go ahead and execute that statement. And now, again, when we do a refresh, Looking at the Temporal Demo DB2, I have my customers table. And then there's the columns for my customers table. My territory manager ID is now a foreign key. However, looking at the historical table, again, it's not set as a foreign key, but simply as an integer. So keys are not recognized in the historical table. They're just stored as integer fields. And we'll see how that's applicable in just a little bit. Before I continue on, Carnegie, can you check the list of the chat window, and let's cover some questions right now?
Okay, absolutely. We've got one question in the chat window that it pertains to entity framework and temporal tables. So the question is from Jamaica, and it asks, I would like to know what is the support of entity framework for temporal tables?
So very good question. As far as entity framework goes, it is not a first-class citizen supported item yet. However, that's going to change in the near future. However, you can create it by using string literals in SQL if you're implementing it through code first, by just simply submitting the create statements such as this, for example, as opposed to utilizing attributes or classes in entity framework. So you can submit a string literal, a SQL string literal that will contain that highlighted portion. That will create the table for you on the database side. And then going forward, you can query it without issue. Do we have any other questions?
Yeah, we just got one more question. Jeffrey asked, how much impact does the use of temporal tables have on read-write performance and storage?
Good question, Jeff. And I will give you the ubiquitous developer answer. It depends. And the reason being is essentially any field that I create in my current table will be duplicated over in my historical table. So am I creating a table full of integers, varchars, binaries, blobs? All that is going to be duplicated in the historical table. And depending on how many fields and of those field types that I create will impact the performance. So it's really hard to give you a specific number, but unfortunately it just depends on that specific scenario.
Okay, and we've got one more question from David. David asked, can I delete records from the history table?
Absolutely. So you can delete them manually, and we'll cover that in just a little bit. You can either delete them manually, you can implement a policy so that the table automatically purges, and then it's more automated as opposed to you having to manually intervene. Okay.
Okay, and that's it for right now, and we will have Q&A time at the end, and just let me know if you want me to interrupt you if we have any questions. Would you like me to bring them to your attention as we go?
We'll stop in another 15 minutes or so, take some more questions, and then we'll handle the majority of them afterwards. Because as we proceed through the demos, I think it's going to answer questions as they come up.
Okay.
All right. So thank you all for your feedback, and please continue to ask questions as needed. So we had left off where we created our customers table and our historical table. Currently, both of those tables have nothing in them. So let's go ahead and populate them with some sample data. So I'll go ahead and create 3 territory managers. And then I will create 3 customers that point to those tables, that utilize those territory managers. And there we see that we have a territory manager ID at the end. And there I'm specifying 1, 2, and 3. And these are customers that are going to specify their names, address, and email. And so we'll go ahead and populate 3 records into the customers table. Now that we have them populated, let's take a look and see what we have so far. So we have 3 in the territory managers, as expected, and 3 in the current customer table. And looking at it, again, I see my sys start time columns that I created, and then my sys end time. Notice that all three fields in the current table, all three rows rather, have a sys end time of infinity, the year 9999, December 31st. And so there's nothing special here. If we look at our historical table, we see that it is completely empty. That's because we made no changes. There's really no history to maintain. We just simply created 3 new records. So now what I'm going to do is I'm going to create a query, and let's assume the scenario where we have a customer who likes to change her email address often, and then she's going to call and complain about why is it that she never received the confirmation email for her shipment. And so in this specific scenario, what I'm going to do is I'm going to update the customer's email to a Yahoo address, then I'm going to change it to a Hotmail address, and then to a fictitious mailx.com address. In between these changes, I have a delay that I'm going to implement. It's a 3-second delay here, as well as here. And so let me go ahead and run these 2 statements, as well as that first update. Notice I'm not delaying for the first change because I've been talking since I've inserted those records, so there's no need to add that additional 3 seconds. So with that, I'll go ahead and click execute. And if we count slowly, 1 through 6, we see that we now have 3 records that have been affected. When we query the customers and the customers historical table, again, in the customers table, we're going to see that all the rows end with the year, with the infinite date time. When we look in the historical table down below, we see all the old email addresses for Tina as she changed it from Outlook to Yahoo to Hotmail. The latest one was mailx.com, as you see above in the current table. Looking in the historical table, we see the sys start time of when that record began to be valid and when it ended being valid. So we have a sys start time and a sys end time. And if you notice, we have our matching date times. So here, when this record was valid from 1936 and 56 seconds up until 1938 and 54 seconds, 0.34. That same date time, when this record ended, this record began. Likewise, when this record ended, this record began to be valid. And then this was valid only up until 1939. Keep in mind, this is by default, it's set to UTC. I'm currently in the Eastern time zone, but this is showing up as UTC. So now I have records in my current table as well as in my historical table. To query them, if you recall, that there's 4 different subclauses that I could be using. So I have an alternate database that I created. I called it Temporal Demo DB as opposed to Temporal Demo DB2. And I'm going to be switching to that momentarily because I already have these predefined records that have been inserted. And so let me go ahead and switch to that database. Now, if we query them, again, it's very similar, except I just have more of the same, meaning more customers records and more historical records. Again, the current table, the sys end time will always be infinity for all the records in the current table. So looking at my customers table, I want to turn back the hands of time to the time January 27th, 2018, and the specific time of 22:37 and 37 seconds. And when I do that, then it will return 3 records, and it will show me that 2 of them are still current, as listed here. But then for the specific time slot that I mentioned, as of 22:37, I see that there was this record that was current between the time 22:37 and 20 seconds and 22:37 and 38 seconds. So it shows me that this record was used, it expired, and is no longer valid, but this was the value for her email at that point in time. Now, obviously, it doesn't highlight just the email address, but rather it stores the entire contents of the record, showing me when it was valid and when that entire record was no longer valid. So this is utilizing the as of subclause. I can continue further and use additional clauses. So if you recall, we said that there's the from to and the between clause. The difference between the from and the between is one includes the boundary and one does not. So the from does not include the boundary. And if we do select star from customers for a specific time frame, so we're looking to see when was a record valid during this time frame. And so we query it. And again, we have similar results to that specific time frame. So these are the records that were valid at that point in time. Notice 2 of them are still valid. They continue to be valid until infinity or until that record changes. So I'm saying, give me the records that were current, between, or that were alive, so to speak, in between this time frame. And these are the records that are returned. When I use the same values down below in the between clause that we see here, and let me close the window down a little bit. When I run the 2, the execute from to and then the between this time and that time, notice the difference in the results. One returned 3 records, the other returned 4 records. And again, that's because this 4th record was this one. It was inclusive of the time frame that was specified, the edge case scenario. So the between essentially includes the boundary, whereas the from does not. And so that's the difference between those 2. Another way that I can query the table is I can specify the contained in, and what the contained in does, it allows me to query records that lived and died within this specified time frame. So it had to expire inside this time window that I'm specifying in the contained clause. And as we see here, one record is returned where it was current at 22:37 and 20 seconds, but it expired at 22:37 and 38 seconds. Another clause that I can utilize for querying is I can specify for system all. And what this will do is it will return both current and historical table. And so there you see everything from both tables. What it does is, behind the scenes, it queries the current table, queries the historical table, and then it unions, if that's a word, unions the result set together and returns that. Lastly, I can just query it the old-fashioned way just by looking at the sys end time, and then I can say, give me everything from the historical table for anything that ended after 2018-127. And when I query that, I get back 3 records there. Okay. Just out of curiosity, Carnegie, how many questions do we have in the chat window at this time?
We've got two questions in the queue at this time.
Okay. Why don't we take them?
Okay. All right. First question is by Brian. Brian asks, how much overhead does a temporal table cost for bulk inserts?
Again, how many fields are you going to be utilizing? And it really varies from one scenario to the other. How much you're inserting. So again, I can't give a definitive answer there. It just depends on that specific scenario. But essentially, if you think of it this way, a performance hit on one table, if you implement temporal tables, you're going to multiply that by 2, because it's not so much the inserts. The inserts are not going to update the historical table, but any updates or deletes to a record will impact the historical table. So inserts alone will not impact the historical table, just the current table, but updates and deletes will impact both.
Okay. All right. And the next question, also by Brian, is can you delete rows out of a temporal table? He has parentheses. The temporal table is not the original table.
So I think he's referring to the historical table there, and the answer is yes. You can do it manually. You can implement a store procedure. You can also implement a policy. So there's multiple ways of purging that table.
Okay. And then we've got one more question here from Jeffrey. The question is, can a temporal table be configured for use with a previously created table that contains a column that is encrypted using a symmetric key encryption?
I'd have to look into that one, but
Well, we can table that. As this might be
yeah, I think we're gonna have to table it.
a great time to interject that we've got a LinkedIn group set up so that any questions that don't get answered here today or during the webinar, we can start a conversation with our LinkedIn group and and get those questions answered.
Absolutely. I don't want to give any misleading answers, and certainly just because the webinar is over doesn't mean that we have to discontinue the conversation. You will have links to both my Twitter, email, and LinkedIn accounts as well. So feel free to engage in any questions afterwards.
Okay, and that's all in the queue for right now.
Okay, very good. All right, so we have, up until this stage, we had created the historical table. We inserted records. We saw what happens when we update the records and the date time recorded. Now we're going to look at some edge case scenarios to see what happens, for example, when we execute things inside of a transaction. So again, here we're going to switch back to our Temporal Demo DB2. And we're going to execute 3 updates. And I don't mean to pick on Tina, my favorite customer here, but I will. So I'm going to change her email address to live1.com, live2, and live4.com. And I'm going to do this inside of a transaction. I have the begin tran here. And then I have, what I'm going to be doing is just simply stating when the transaction started. I'm going to print that out. And then I have some delays that are built in. There's a 4-second delay here, another 3-second delay, and then I specify when the transaction ended. And what I'm going to do for starters is I'm going to comment out the commits and uncomment the rollback. And before I execute that transaction, I just want to give you an idea of what we have in our database. So we have both 3 records in our current table and then 3 records over in our historical table. So with that said, and again, Tina's email is currently tina1@mailx.com. She had a Outlook, Yahoo, and Hotmail addresses. And now we're going to go and give her fictitious live addresses in a transaction. But we're going to roll back the transaction. We're not going to let it commit. So let's see what happens when we do that scenario. So we'll go ahead and execute. And there's a brief 7-second delay. And there we see the transaction starting at. There's the time window. What happened here? Okay, it says committing, even though it really didn't commit. And then the transaction rolled back. So if we look at the results of our customers and the historical table, again, we see only 3 records in the current table and only 3 records in the historical table. So we made updates, however, we rolled back the transaction, and so none of it appears in either the current table or the historical table. Now we're going to do the same thing, except this time we're going to commit. We'll execute that, and we'll have a brief pause in between the 2 records so that we can see the time difference. And now that it had committed the changes, let's take a look at our customers table and our historical table. And so there you see the latest email address for Tina is live4.com. And then there you see that we had live1.com and live2.com. Now, if you look at the messages, shoot. Okay, I accidentally switched over before noting the transaction start time. So what happens is when you execute it in a transaction, is that essentially it uses the begin time of the transaction in UTC. And so looking at the Tina Wilson for live 1 and live 2, we see that the sys start time, this is the time slot that was used. This is the beginning of the transaction, and it was used for both the sys start time of that field and the sys end time of that record as well. So it uses, when we're using it in a transaction, it uses the begin time the transaction started for both the sys start time and the sys end time fields. So looking at the historical table, we have several addresses for Tina, and what we're going to do is we're going to delete a specific record from the historical table where her address was tinaw@outlook.com. So we'll go ahead and delete that. And you see that it cannot be deleted, and the reason for that is that we still have versioning turned on, meaning the two tables, the current table and the historical table, are married together. So one change to the other, it will affect, the change to the current table will affect the historical table. Likewise, we cannot make any changes to either at this time. So what if, and a minute ago, someone asked, can we delete records from the historical table? And I said, yes. The caveat is, you notice that we said that we have system versioning set to on. In order for us to make any changes, we need to turn system versioning off. So we'll go ahead and do that here. We'll turn the system versioning off. Now we can delete records from the historical table. You see that there's that row was removed. In addition, while I have the system versioning off, what I want to do is, let's say I want to make a change to my current table. Actually, let me do this. Let me turn system versioning back on. And I'll explain what this clause or what this statement does in a second. So now I have system versioning turned back on. And let's say that we get a request from our business analysts where we need to add a field called alternate email into our customers table. So we go ahead and alternate or alter the table by specifying that we're adding alt email varchar 20, and it's an allable field. We go ahead and execute that. Now you see that change took place. Now, when we take a look at our historical table, let's do a refresh. So we have the customers table and the customers historical table. And so in our customers table, we have alt email. And in our customers historical table, we have another alternate email as well. So when system versioning is turned on, we're able to make the change and have it take place into both tables. Now, obviously, this is a little bit of a bad practice because I didn't specify a default value, and it is set as a null field anyways. So, but let's assume a different scenario. Now, let's turn system versioning off. We execute that. Now system versioning is turned off. I'm going to add another field, and I'm going to call it alternate email 2. I'll go ahead and alter that. And that took place no problem. And I notice here, I just made the change to the customers table, my current table only. Now at this stage, I'm going to turn system versioning back on. And what this is doing is specifying that system versioning is going to be turned on. In an alter table statement, I'm specifying the name of the historical table that it's going to point to, and I'm specifying data consistency check equals to on. So I'll go ahead and execute that, and we see that it failed. Looking closer at the error message that I'm getting, we see that it's specifying that it's specifying the Temporal DB2 customers table has 10 columns, but the Temporal DB2 customers historical table has 9 columns. So in order for us to maintain history or to have system versioning turned on, basically we need to have both tables in sync together. And so now what I'm going to do is I'm going to do the same thing, alternate email to the historical table, add that in there. Incorrect sequence. Oh, I didn't highlight the whole statement. All right, let's try it again. All right, so that completed successfully. Now both tables have the same structure, and when I turn it back on, everything is running correctly again. So for that purpose, as best practice, it is highly recommended that when you make changes to the table, do it inside of a transaction. So as you see here, initially my intention was to do it in a transaction. However, I wanted to show you the wrong way of doing it and the errors that you could encounter. And so with that, I just need to keep in mind that we need to turn system versioning off, make changes to both tables, or make the changes to the tables while system versioning is on. But if you make changes to one table and not the other, and then turn system versioning on, that's going to cause a problem. Okay. And so now we can continue to go through and we can query both tables just as we did previously. And we see the records are still existing there. So I can delete from the customers table. So I have a customer with an ID of 1, and that's Lisa Shepard here. So let's see what happens when I actually delete that customer from there. And then I query both tables. So I see that customer ID 1 no longer exists in the current table up above, but in the historical table, the last record, and let me close the Object Explorer, the last record specified there has the Lisa Shepard record. There are my alternate email addresses that I added, and then here are my sys start time and sys end time. So it shows that this record was valid from 1936 and 56 seconds to 1959 and 56 seconds, but there is no corresponding record in the current table because it has been deleted. So in the case that this was deleted by accident, I could just simply copy from the historical table into my current table like I would any other table. And just to specify the historical tables, so a couple key things. When you're creating your historical table, if you just simply specify system versioning on without specifying a name of the historical table, it's going to give you a rather odd looking name because, again, you didn't specify a name for it. So let's take a look at that naming mechanism. So here I'm going to create a department 1 table, and it will have, again, our primary key. It will have the sys start time and sys end time with the generated always as row start. My sys time fields specified, but notice no name specified for the historical table. So I'll go ahead and execute that statement. Looking over in my DB2, when I refresh that, I see that I have department 1, and there's the icon for a historical system version table. The name that it assigned the historical table Basically, the default convention is MS-SQL underscore temporal history 4 underscore the name of the or the object ID for that table name. So it's not quite an easy roll off the tongue name, but it does give you another name that you can reference that table by. So this is one method. You don't have to specify it, but if you don't, it will give you a rather odd looking name for the historical table. The other method is I can just simply specify the name of the historical table like we did previously. And there is Department 2. And there we see I specified Department 2, and I want it to be called Department 2 History, as specified in this subclause here. History table equals dbo.department2 history. Last but not least, I can also specify a schema for my historical table. And then, so this is in the case where I want to create a specific index on the table itself that's going to vary from my current table. So here I have a Department 3 history. I'm going to create that table. And if you notice here, I just specified system start time, date time to type. I didn't specify the clauses because this is going to be my historical table. I didn't say generated always as row start. So Department 3 history is my historical table. Now I'm going to implement specific column store indexes on it. And go ahead and execute that. Now I'm going to create my Department 3 table that will be married to my Department 3 history table that was previously defined up above here. Okay, so with that, again, I'm specifying my primary key, my date time fields with the row start, my period with a system designation for the sys time, sys start, and sys end. I'm specifying system versioning on, and I'm specifying the name of my custom historical table that I created. And so that executed successfully. Okay. All right. It's now 4:05. Let's go to the chat window and see what questions we have waiting for us, Carnegie.
Okay, Sam. We got one question in our question window here, and it's by Jeffrey. And Jeffrey asks, are temporal tables backed up in the same manner as normal tables? If so, do temporal tables make use of a transaction log, which needs to be maintained for tables set to use a full recovery model?
Yes, that they are backed up like other tables because they are essentially treated like other tables. The only difference is when I specify system versioning on, it is basically marrying the two. Whenever I make an update to the current table, it will automatically be reflected in my historical table as well. But for all intents and purposes, I can treat them as separate tables.
Okay, and that's it so far here in our question window.
Okay, very good. All right, so let's go back to our slides. We have some additional things to discuss. So when we're creating a table, a couple things to keep in mind. The file stream feature, and if you're not familiar with file stream, you're missing out. It is a pretty cool feature that was introduced in SQL Server 2008. And unfortunately, that feature is not supported with the temporal tables yet. However, as we all know, things change from version to version. And the history table cannot be modified directly. You can only add to it or update by deleting data from the current table. That is if you have system versioning turned on. If you turn it off, then you can make changes to either table. Because when you turn system versioning off, essentially the tables are separated, or they're treated as separate entities. There's also some additional caveats. So like I said before, they are treated as normal tables, but there are some things and limitations that go into place. So for example, instead of triggers are not supported, but after triggers are only allowed on the current table. So there are some limitations there, and there's a link at the end of my slide deck that points to the Microsoft Docs and they do a great job of detailing all these items. It is far more than what I can list here, but I did want to just touch on it briefly that there are some constraints and limitations to them. Indexing must be manually enabled, as we had seen previously. You cannot change the schema of a temporal table without changing the current table schema, and that's because they both essentially work in unison. So once we turn system versioning on, then the two tables are identical to each other as far as the schema goes, with exception of foreign keys and primary keys. And changes to the current table will automatically reflect on the temporal table automatically. When I had the system versioning turned on, if you recall, and I added a new column, it automatically reflected in the historical table or the temporal table. So when I set my system versioning equal to on, this is a list of the things that happen. Basically, when I set system versioning to off, they're treated as two separate tables. When I set it back to on, it goes through a checklist to make sure that everything is still kosher and will work together. So it looks to see that the names and the number of columns is the same in both the current and the historical table. The data types match. The nullability of the columns, specifically the period columns, are set to not null. All the other things that are listed there. The current table has to have the primary key constraint, and the history table does not have a primary key, as we talked about. Same thing with the identity columns. They're defined in the primary table or the current table, but not the historical table. No triggers are defined in the history table, no foreign keys in the history table either. And then, as you see on bullet point number 8, no table or column constraints are defined on the history table. However, default column values on the history table are permitted. And that's, if you think of a scenario where you're adding in a field that is not null, obviously you're going to have to specify a default value there. And the history table is not, it also checks that the history table is not placed in a read-only file group. So in case you had moved the table out of the file group into another location, it checks to see that it is still accessible and can make those changes before it will give you the thumbs up that system versioning is on. Lastly, keep in mind that the history table is not configured for change tracking or change data capture. It tells you what records have changed. It doesn't tell you the who did it. So it basically, and it doesn't tell you what changed either. It simply records the entire record, and then it is up for you to see what has changed in between the two. Some security principles that apply. So basically, I will sum this up in a nutshell, saying that I have full control of what I can grant my users. They can see access to the historical table, or I can limit them from seeing the historical table results, and rather only the current table. So basically, I can apply select permissions to the historical table just the same way that I can with the current table. Some best practices. For converting an existing table, consider using the hidden clause to hide the new period columns. So what this is referring to is, if you recall, we said that we have the sys start time and sys end time columns. If I'm going to be adding that to an existing table, I should set those to hidden, because there may be applications that implement a select star from a table. And if those columns come back, the application might not be able to handle them. So I can implement those columns as hidden, and I can still continue to use my table, and it pretty much minimizes any issue arising from any applications that could be querying the data using a select star from. The second bullet, pay close attention to whenever you're querying as far as the less than or less than greater than equal to. It's basically whether you're including or excluding the boundaries whenever you're specifying the system date time. Also, consider using a separate schema for the historical table. This will help provide better security on it as well, and then it'll keep things more organized. And lastly, I didn't list it here, but certainly discussed it. Utilize transactions whenever you're making changes to the tables. Some resources that are listed here. Again, Microsoft Docs has done a great job of documenting it. And so it gives you a great overview as far as the temporal tables and implementing security. Some considerations and limitations. We touched on it a bit, but that list is long and lengthy and goes into great detail. So if you have any questions about can I implement this, can I implement that, I would certainly check that third link that you see there. Also, you can manage the retention of the historical data and specify how long you want data to be maintained in that historical table, so that way it doesn't get to be ridiculous. And last but not least, at the very bottom, changing the schema of a system version table. There talks about it in more detail, similar to the demo that I had walked through with you. My contact information, snasser@nistechnologies.com. Please feel free to email me with any questions, either now or later. Also, I would love it if you'd connect with me on Twitter and LinkedIn. You can find me there. My Twitter handle is @SamNasser. And Carnegie, do we have time to just briefly discuss implementing this in Azure?
Yes. We have a few minutes. We can discuss that.
Okay. So temporal tables is applicable to SQL Server as well as in SQL Azure. So what I have here, let me minimize this. I have another connection to my Azure database that I created. There is my connection string, nistechnologies.database.windows.net. And then from here, once I make that connection, then I can see my temporal demo Azure DB. And okay, so I'm connected there. Let me verify my connection string. All right, so we're good. Now I can query my customers and customers historical table, and it essentially works the same identical way through Management Studio, where I can retrieve the records. I can see the sys start and sys end time. And I can make changes to the data as needed. So let's take a look again, similar. This is an identical example of what we run previously on my local database, but I will do it in Azure. So if you recall, this is where we start the transaction. And we're going to change Tina's email multiple times and then commit the transactions. So if we go ahead and execute that, and there is a 7-second delay here. And this time, I will note the start time of the transaction. So 2014 and 58 seconds. And now when I query the tables, let's get this out of the way. There I see the sys start time and sys end time, both having that begin start time in UTC. That was the start time of the transaction as opposed to the commit time of the transaction. So that's one thing to keep in mind when you're running transactions like this with updates, is that it records the begin time and not the end time. Other than that, it's essentially identical to everything that we discussed in previously, that the previous demo was executed locally. This Azure demo is obviously connecting to an Azure database, but through the beauty of SQL Server Management Studio, the same operations can be implemented the same way. I have access to my tables. Everything appears as it would in my local database. And everything carries over. So with that, again, let me pull up my contact information, and let's take a minute to answer any questions that are remaining in the chat window.
Okay, great, Sam. Can you hear me?
Yes, sir.
Oh, great. We've got one question in the chat window here, and we've got time for just this question, and we can continue the conversation in our LinkedIn group if we have other questions that come up. And the question is asked by David. It asks, is there a way to keep history tables in another database?
In another database. I know you can do it in another schema. I'm not sure if you can do it in another database. I would gamble and say yes, but email me and I'll be happy to follow up with you on that.
Yeah, it's a great way. Like I was just saying, the follow up. Yeah, we can move this conversation to our LinkedIn group and get David some help with that.
Absolutely. And so again, my contact information here at Sam Nasser. You can find me on Twitter, LinkedIn, or good old-fashioned email. And with that, I will turn it over to Carnegie.
Okay, thank you everyone for your time. I know we went over a little bit. We're new leaders, so we're trying to get things polished up. So hopefully, our next webinar is going to be June 28th. How slow applications affect your bottom line. So stay tuned. We're going to have another great giveaway. Please visit our website appdev.pas.org where you can find this meeting recording, a link to the content, the demos, and the slides. And also, don't forget to get your bonus entries by connecting with us through social media, Twitter, and LinkedIn. So once again, thank you, everyone, and have a great rest of your day.
Thank you, everyone.